Good morning, students. Myself, Santosh Kumar, Assistant Professor in Chemistry, MR College, Vizianagaram. Today, our topic is UV spectroscopy problems. What is UV spectroscopy? What is principle of UV spectroscopy? UV spectroscopy is a ultraviolet spectroscopy. The molecule is observed by some certain wavelength of the UV radiation. That range of radiation is 200 to 400 nanometers. What is principle? Electronic transitions. So electronic transition takes place between the energy levels in a molecule by absorbing the certain wavelength of UV radiation. Then it can be very useful for determination of the conjugated dienes, alpha beta unsaturated carbonic compounds, aromatic compounds, non-aromatic compounds. So these molecules have some basic values. The basic values can be explained by the Woodward Fischer rules. So then we learn Woodward Fischer rule. Woodward Fischer rules for conjugated system. Conjugated diene. Conjugate diene is nothing but 1,3-butadiene is a basic structure. So here the basic structure of the conjugate diene is 1,3-butadiene. Conjugation means the alternate double bonds present in the molecule. Here these conjugate dienes may have cyclic or acyclic. So then acyclic conjugate dienes, cyclic conjugated dienes having basic value is 217 nanometers. 217 nanometers. In cyclic conjugate dienes are two types, that is homo and hetero. Homoannular, heteroannular. Homoannular means the two double bonds present in the same ring. The two double bonds present in the same ring is a homoannular. The two double bonds present in the different ring. So then the absorbed UV radiation on this molecule to give the 253 nanometers lambda maximum value. So in this heteroannular we get 250 nanometers lambda maximum value. I will ask you one question. If the cyclic conjugate diene having two types of annulars, these two types of annulars present in the one molecule, what will we take basic value of this molecule? So here this molecule having both heteroannular and homoannular is observed. Any of the molecule we considered highest lambda maximum value in UV radiation, UV range, we will take the as a basic value. So then we will also take this molecule 253 nanometers is a lambda maximum value for this molecule. So another question. First, when our examinations, we observe the first molecule is acyclic or acyclic. First we have to know. Here this molecule is acyclic or acyclic? cyclic compound. If the cyclic compound, so we are going to the definition. Homoannular means the two double bonds present in the same ring. Here the double bond, one of the double bond is inner, one of the double bond is outer. Heteroannular means the two double bonds present in different rings. Here only one ring is present, not another ring. So it is the both definitions are not possible to give this molecule. So it is, we confirm it is a cyclic conjugated diene. Then the basic value 217. 217. Some of the substituents present on these basic conjugate dienes. So that are substituents may have give some absorption takes place in a molecule. So only that absorption of the UV radiation on conjugate system only. When these conjugate systems are attached to the substituents or any other increments present in these conjugate systems, they will get some of the values, basic values. Then we will learn substituents or increments. Substituents or increments. Substituents. The substituents may have attached to the conjugate system only. So three types of substituents are observed. That is the alkyl substituent, or ring residue. Alkyl substituent or ring residue. What is alkyl substituent? Alkyl substituent means the alkyl groups like CH3, CH2, CH or C. These are the alkyl substituents present on the conjugate system. For example, this is the conjugate system. So these conjugate systems, the carbon-carbon, when the substituents present on these conjugate system only, if the conjugate systems having some substituents, then they will get another absorption takes place. So that they have some have basic value. That is the 5 nanometers. Another case, ring residue. Ring residue means we observe the alkyl substituent in ring form. Here the conjugate systems is here like this. This is the conjugate system. These substituents present on the conjugate systems, that is the carbon attached substituent, these carbonatic substituent, these carbonate substituent. Then this is these three are the alkyl substituent or ring residues. Then these molecule having 3 into 5, 15 nanometers. So like this, alkyl substituent ring residue. Not only alkyl groups present in the conjugate systems, some of the oxochromos are also present on the conjugate system also. Here if the chlorine attached to the conjugate system, then we will give the basic value is 0.5 nanometers. If the bromine is present in this conjugate system, they have 0.6 nanometers. OH also having 0.6 nanometers. Second one, exocyclic double bond. Exo means outer ring. Outer ring double bond. Outer ring double bond. The double bond which is attached to the conjugate systems is outside of the ring. Here we observe this molecule. One ring is present. One double bond is outside of the ring. Another double bond is inside of the ring. So then these have another increment is exocyclic double bond. If the fusel rings observed, we observe the fusel ring. We can't show the outer exocyclic double bond, but we have to write these two rings like this. So we consider this ring as a we consider this ring as a B. So A ring please bring the A ring by outside. So here, so like this can be write. This is the A ring. This B ring. You can write like this, B ring. So then the A ring, B ring. So here you look these two rings. So one of the ring is outside of the double bond is present. So then these molecule having 1 into 5 nanometers. Another last substituent or increment is extended double bond. Extended double bond is nothing but extension, not extra. Extension takes place in a molecule. That means extended double bond is nothing but the double bond is extended to the conjugate system. For example, in this molecule, so this is the conjugate system. Except these conjugate systems, remaining double bonds are extended double bond. So here you see 1, 2, 3, 4, 5, 6, 7, 8. The conjugate systems must have 4 carbons. So remaining carbons are extended to the double bond. Here 5, 6, 7, 8 is the extension takes place. So then these have 2 extend double bond. These have basic values 30 nanometers. 30 nanometers. So then 2 into 30, 60. You see this molecule. Here also, except conjugate system, another double bond is present with extension. How it is? 1, 2, 3, 4, 5, 6. 4 carbons except 5, 6 is also having double bond. So then this is the extension. Then these have 1 extend double bond. I will ask you one question. Is this molecule, is this compound having extend double bond or not? No. Why? Because here we consider like this 1, 2, 3, 4. This double bond is not extended to the conjugate system. So another we will take 1, 2, 3, 4. This double bond is not extended to double bond. 1, 2, 3, 4, 5. So this double bond is not considered extended to the double bond. So then this molecule doesn't have extended double bond. So I will give you an example. Then you will write lambda maximum value. Okay. For example, this molecule. So first we have to see this molecule, acyclic or cyclic. It is the acyclic compound, then acyclic conjugate system. Conjugate diene, the basic value is 217 nanometers. Next, you must be see the conjugate increments. First increment is alkyl substituents. Alkyl substituent means the double bonds, the conjugate systems is attached to the substituents. So these all double bonds are conjugation. So here some substituents on these conjugate systems. This alkyl group, this alkyl group. 4 types. 4 alkyl substituents present in the molecule. Then 4 alkyl substituents, 4 into 5, then 20 nanometers. Next increment is exocyclic. It is not a cyclic compound, so we not consider this molecule, that increment. Another increment is extended double bond. So here, except conjugate system of the basic structure, so remains double bond is the extended double bond. So with conjugation, with extension also. This is 1, 2, 3, 4 and 5, 6. So then 1 extended double bond is present, then it is 30 nanometers. So finally, this molecule having lambda maximum value is 267 nanometers. Lambda maximum value is observed. Second example. See the molecule. It is a cyclic or acyclic? This is cyclic compound. And in cyclic are 2 types, heteroannular and homoannular. Hetero, homo, both are present in these annulars. So then, what will take? Homoannular. So then, homoannular conjugate diene basic value is 253 nanometers. After, we have to see increments. First increment is alkyl substitute or ring residues. In order, conjugate systems is attached to the substituents. 1, 2, 3, 4. 4 types of 4 ring residues are present in this molecule. alkyl substance. Then ring residue 4 into 5 is 20 nanometers. Next one, exocycle. So this is A, we consider A, this is B. So then you see outside here, like this molecule, double bond is present here, double bond and inside the ring. So both rings having exocyclic. Then exocyclic double bonds Db 2 then 5 is equal to 10 nanometers. Extend double bond, extension. Next one, extended Db is here 1, 2, 3, 4, 5, 6. So this double bond is extended to the conjugated basic structure. So then 1 into 30, that 30 nanometers. Then we will get 781,313 nanometers. Simple. This is the simple structure. Thank you.